Greetings, everyone. My name is Derek Smith, and I am an Azure Cloud Evangelist at Trace3. My primary role specializes in spending a lot of time within the Azure community, evangelizing the Azure Cloud, all of its various offerings and services on behalf of Trace3. Now, today we're going to be talking about how you can level up your skills with Azure Virtual WAN. I like to spend a lot of time with Azure networking and Azure security, and they are big passions of mine. And so as Azure begins to scale even greater within the cloud ecosystem and with the introduction of enterprise scale landing zones, I feel it appropriate to discuss one of the primary networking resources that can really help you implement within your organization or with your clients a true hub and spoke architecture that can scale as your cloud environment scales. Now, connectivity can be fairly messy. There's a lot of different connectivity options, limitations with one-off solutions. There can be operational model challenges with different panes of glass for monitoring, configuration, setup, and you name it. Now, traditionally, from a networking perspective, a lot of organizations tend to blame the network when things go wrong. And a lot of us old data center network engineers know that phrase all too well. However, I'll discuss how we can kind of flip that phrase around and really harden the network from any sort of outages or latency issues or durability destinations. Now, obviously, we will be talking about a software-defined shift as we are in the cloud, and this particular service does have a large SD-WAN component to it, and the way it integrates within existing third-party vendor offerings. And obviously, we'll be discussing network security and how best we can implement a zero-trust model within our enterprise-scale landing zone or hub-and-spoke architecture, and how that best lends itself to ensuring that our network topology is secure and trusted, and how we can ensure various workloads are isolated. And obviously, that all can be simplified with the Azure Virtual WAN service. Back in 2018, Microsoft had this vision of bringing together all of the various networking, security, and routing capabilities they had developed to date into a unified SD-WAN as a service cloud-based offering, backed by the global network architecture that Microsoft owns that is pure fiber at your disposal. From an overview perspective, we'll be discussing connectivity options, that global transit architecture, how we secure a virtual hub. We'll focus in on routing and how to implement these advanced routing scenarios within Azure Virtual WAN. And additionally, we'll talk about some of the integrated network virtual appliances you can deploy within Azure Virtual WAN hubs. From a connectivity standpoint, Azure Virtual WAN supports your site-to-site VPNs, your point-to-site VPNs, and express route connectivity options. Each of these gateways is deployed directly into the Virtual WAN hub, supports all of the traditional offerings that you would expect from a normal virtual network gateway, for express route or site-to-site VPN or point-to-site VPN. However, because this is Azure Virtual WAN, their scale has been ramped up almost tenfold, which is what makes deploying Azure Virtual WAN with any one of these connectivity options truly attractive for a lot of organizations. You just get greater scale, greater benefits from throughput perspective, as well as a lot of the newer features that Microsoft is deploying for each one of these services tends to land in Azure Virtual WAN first before it lands in the virtual network gateway. As we discussed earlier, there is a way to integrate some existing third-party SD-WAN offerings directly into Azure Virtual WAN. So if you have an existing, say, Cisco solution, Meraki solution, VMware, Palo Alto, Checkpoint, Fortinet, Barracuda, there's a huge long list on the Microsoft Docs page that talks about all of the various vendors that are supported. You can leverage their SD-WAN solution on top of your Azure Virtual WAN solution to create automation in a way that will easily connect and spin up all of your various branch locations through a site-to-site VPN connection with little to zero touch from you within the cloud. And it's what truly makes Azure Virtual WAN an enhanced offering from that perspective. Now, you don't necessarily have to leverage any one of these third parties. Azure Virtual WAN can do all of these on its own, but obviously when you add in these third-party solutions, you can just enhance that even further. Now, Azure Virtual WAN does take advantage of Microsoft's global network fiber architecture, allowing you to have a fully meshed hub environment. And what this means is any hub that is deployed within an Azure region is automatically connected to any other hub that is deployed in that virtual WAN instance, allowing you to have this any-to-any connectivity. So whether it's a branch to Azure connection, branch to branch, site end users to branch, vnet to vnet, or even between your vnet, VPN, and express route, has that transitive capability. And so this truly makes Azure Virtual WAN a network solution for any situation, for any customer. Now, what helps facilitate this capability is the virtual hub router. You get one router per virtual hub. It controls all of the routes between your various gateways as well as your virtual networks and their connections. It does have a upper limit of 50 gigs of aggregate throughput per hub. So that is something to keep in mind if you need low latency or have latency sensitive applications that might exceed this type of threshold, or you're running a large workload like SAP HANA or a data warehousing, you'll need to take that into consideration. Now, what truly makes the routing portion of this even better is traditionally we've been used to these user-defined routes within Azure where we have to statically enter all of these various route tables, associate them to subnets or vNets. Now, within Azure Virtual WAN, we have the ability to create a custom route table for virtual networks. Our branches get a single route table for all of their connections, but you can associate these route tables to the various connections for them to not only view those effective routes, but you can propagate routes from those connections to the route tables. So this is truly a dynamic routing solution within the cloud. Recently, back in 2019, Microsoft got a lot of feedback from customers that were leveraging Azure Virtual WAN, basically saying, hey, the setup of putting a network virtual appliance behind my Azure Virtual Hub just isn't working for me. My security department needs more visibility, needs to see that traffic coming in right at the hub, right at the edge. And so Microsoft took their Azure Firewall solution and integrated it directly into the Azure Virtual Hub, creating this secure virtual hub. What this allowed you to envision now is a secure security as this secure edge capability, and they added in a capability with their security as a service partners. So right now, the supported partners are Zscaler, iBoss, and Checkpoint, and you leverage Azure Firewall Manager to create policies and apply those policies across multiple secure virtual hubs or multiple firewalls, and you get to secure your VNet to internet or branch to internet traffic, as well as private traffic from VNet to branch. Now, if you are going from secure virtual hub to secure virtual hub, that current routing scenario is not supported. So case in point is if I have a HQ branch located in East US 2 and I'm trying to send traffic to a virtual network that's located in West US 2, that traffic will not be inspected or controlled by Azure Firewall. In fact, it'll just bypass it given the current state of Azure Virtual WAN. And then finally, Microsoft took a look at some of the newer network virtual appliance SD-WAN solutions and said, hey, how can we start integrating those appliances directly into Azure Virtual WAN? And obviously, two partners came to mind when they started looking at implementing this type of solution within Azure Virtual WAN, Barracuda and Cisco, Cisco Vitella to be specific. And so what we get now is a managed instance of Barracuda or Cisco's solution within the virtual hub. And so what this allows is you to have a secure access service edge within your secure virtual hub with the Azure Firewall. You have built-in resiliency, right? No need to set up a VM scale set or a VM availability zone. any of those sort of traditional infrastructure requirements, routing is all controlled through the traditional virtual WAN routing method. You don't have to log into these virtual appliances to configure routing in two different places between the virtual WAN and this network virtual appliance. And you still get all the advantages of the provider's proprietary features. So I can take advantage of all of the Barracuda features or all of the Cisco Viptela features without sacrificing any of that capability. So putting it all together, we have our virtual WAN instances. What makes them truly unique, again, is this idea that they support all of the various connectivity models, and we have built-in security directly into the virtual hubs themselves through either Azure Firewall or one of the supported security as a service partners. The scale of Azure Virtual WAN is far greater than the standalone virtual network virtual network gateways that you see in a traditional Azure hub and spoke architecture. Greater scale from a point-to-site VPN, 100,000 users per hub, 200 gigabits of aggregate throughput. Site-to-site VPN, 1,000 connections, 20 gigs of aggregate throughput, and then vnet to vnet, 500 virtual network connections per hub with 50 gigs of aggregate throughput. Now, the one where I say from a scale perspective, there might be some people being like, oh, well, with ExpressRoute, you can't quite. Yes, if I have the ability to leverage ExpressRoute Direct or ExpressRoute Local, where that has 50 and 100 gigabits per second express routes, yes, unfortunately, vWAN isn't going to support those type of situations. However, a lot of the other customers you're looking at, 500 megabits per second, a gig, 2 gig, 5 gig. Virtual WAN can help support those type of express route connections and aggregate up to 8 express route circuits to a single hub. And then the transitive routing capability all through that managed virtual hub router is truly unique. You don't have to worry about managing a specific network virtual appliance behind the scenes. That router is managed for you by Microsoft. All of your hubs are automatically integrated. You get transitive capability between VPN, ExpressRoute, all of your virtual networks, and then the ability to have dynamic custom routing from your virtual networks where they're learning routes from either the branch locations or other virtual networks within your environment. You don't have to constantly go in and make changes to those users-defined routes. Those route tables can dynamically learn new networks, new routes, as you associate your route table to new connections or new labels to propagate those routes. Now, when it comes to routing, and the reason why I feel this is where a lot of people can help level up their skills with Azure Virtual WAN is I've gone through multiple Azure Virtual WAN deployments. Deploying a VPN, deploying an ExpressRoute gateway, deploying a point-to-site gateway is very easy, very straightforward. It's just like how you would do it from a virtual network gateway perspective. So there really isn't anything different or special outside of selecting the different scale units within Azure Virtual WAN, where I see a lot of Azure administrators or folks new to Azure Virtual WAN looking to implement this service is when it comes to routing. And the reason is because routing is different from the user-defined routes that you would traditionally deal with from an Azure administrator perspective. So a basic use case scenario, and this is what you would see right out of the gate if I were to deploy an Azure Virtual WAN environment today. It's automatically set up for any-to-any. So what this means is my VPN connection, my ExpressRoute connection, my point-to-site configuration connection on my virtual networks, all of those would be assigned to a single route table. And those connections would then learn routes from that associated route table, right? And this would be the default route table. This is the one that's created every time you spin up a virtual hub. It's always there. You can't get rid of it outside of the second one that's there. Trick question. There is a second one that is created. It's called the none route table. We'll discuss what that is a little bit later on. But this default route table then can propagate routes to the route table and then learns routes from associated route tables. So case in point, all of my branch locations, the 192.168.1.2.3, is automatically populated within this default route table because of my various connections, and then my VNet connections, because they're associated to this route table, their networks are learned as well via their connection IDs. And so this sets up the truly any-to-any routing capability of Azure Virtual WAN. It is its default architecture. So the question is what if we don't want any-to-any? How would we go about configuring this? Well, Azure gives us the ability to create a custom route table and create custom routes. Now, these can only be associated to virtual networks. It is not supported at this time to associate a custom route table with your branch connections. Hopefully that is something that Microsoft is working on. And as we get more information and talk with the product team, I know that's something that would be greatly beneficial to add to this particular service. Now, if I want to create a custom route table, I can name it something like RT_VNet, right? And I'm going to associate all of my VNet connections to this route table. So say I am coming from this little IP over here, 10.3.0.5, and I would like to reach one of my branch locations. Well, the good news is because they're all contiguous address spaces, I can put in a 192.168.0.0/16 address, right? Associate that next hop with my VNet 3 connection, and then put in a specific route for that connection and say, hey, if I'm coming from VNet 3 and I want to go ahead and get to my on-prem locations, right, I need to route through 10.3.0.5. And so maybe that's a network virtual appliance. Maybe it's some type of route server or some other type of network NVA or firewall router, you name it. So that becomes a static route that gets added. Very much similar to our user-defined route tables, right? When we put in, hey, I want to go to a virtual network gateway, right? I need to put in that specific IP for that next hop, so I know to send traffic to the front end or back end of that IP. Maybe it's a load balancer, something of that nature. So similar concept from that perspective. Now, we talked about zero trust and how do we isolate workloads from each other. So the unfortunate bad news is I cannot isolate different branches from each other, so to speak. However, I can isolate my virtual network workloads from each other. You can turn off branch to branch if you so choose. I wouldn't necessarily recommend doing that from that perspective, but you do have that capability within Azure Virtual WAN. As we'll see as we walk through the demo, you can actually turn off branch to branch routing. But the good news is if I am in a cloud first architecture where a lot of my workloads may live in the cloud, right? I want to prevent people from getting to my workloads. My express route connection or my site-to-site VPN connection, there may not be really anything of note down there from a network traffic perspective. So my default route table is still going to have those associated connections. And then it's going to have the connections not only to Virtual Network 1, but also Virtual Network 2. Now, what we are isolating is the ability for those workloads to talk to each other. And in this instance, will prevent that lateral movement. So if there is a workload that is compromised in VNet 1, I can't transitively access anything in Virtual Network 2 because there is no route that exists, so they have no idea how to get there. And so that's the type of custom route table we associate to each one of those VNet connections. You can still get to on-prem with those site-to-site VPN ID and express route connection ID routes, but I do not have any idea how to get to my other virtual networks, so they are effectively isolated from each other. Now, in a similar example with our earlier scenario, we talked about VNet 3, it having a specific static route to go through maybe something like a static IP, 10.3.0.5, maybe that's a network virtual appliance. But what if it's not a specific IP? What if it's a third virtual network that maybe hosts a number of shared services? What use case would that look like? And so, much like our previous example, we would add in VNet 3. The difference here is when we associate our default route table and our new custom route table, we're going to add in the virtual network 3 connection ID. And then from a virtual network 3 perspective, I'm going to specify a next hop in that vNet connection. And we'll see in our demo how specifically when you set up those virtual network connection IDs that you can specify, hey, there's a device that I want my traffic going through in order to control how to get there from a routing perspective, right? So there's specific endpoint, maybe it's a load balancer, maybe it's a VM, right? That controls that traffic from getting there. Now, broadening our isolation scenario, diving further down zero trust network security, what if my environment was bigger? What if I had multiple VNets, multiple hubs, multiple branch locations? How would I isolate that traffic? And so the common example here is to associate similar workloads with each other. And so we'll use this example of blue net, orange net. Now, in this example, my branches can still get to each other. So they will have the exact same route table. Their site-to-site VPN connections, as well as their express route connections, will be within my default route table. So branch to branch will work. They'll know how to get to each other. Now, the difference here is I'm going to create 2 route tables. And specifically, each of these route tables is going to have a different label. I'm going to label one blue, and I'll label the other orange. And the reason being is I only want the orange labels to get route propagation from those similar VNets. Same thing with the blue. That blue label is going to get route propagations from only the connections that have the blue label. So again, I'm going to propagate all of my branch locations because I don't want to keep my end users, whether they are at a branch location or headquarters, or maybe they're on some SSL VPN, right? I want to make sure they can access the workloads needed in order to complete their tasks. But I don't want blue talking to orange, and I don't want orange talking to blue. So my blue label will only get VNet connections 1 and 3, and then my orange connections will only get 2 and 4. So they'll have no idea how to reach each other, effectively isolating them and not allowing any lateral movement. And then my branch locations will get all 4 VNet connections. Now, in a any-to-any scenario, building upon our early example, this would be much the same. You'll have that single route table, single label. All of the various connection IDs will be available in that default route table, enabling a multi-hub any-to-any connection, right? Because of that automatic, fully meshed connectivity model. When you spin up your second hub, it'll establish that connection within the backend, and then any user, no matter where they're located, will get routed to the correct virtual network resource, no matter where they sit. Now, what if I want to add in something like an Azure firewall and control my internet edge, right? What if I want my VNets to go to the internet via the firewall instead of the Azure edge? What if I want my branch users to not go out the internet through maybe a local appliance? Maybe I want to standardize or centralize everything on an Azure firewall. So what would that look like? Again, default route table, going to be standard across all of my branch connections with all of the virtual networks. Now what we're going to do from this instance instead is we're going to drop in that famous quad 0 static route and specify our next hop as the Azure firewall. Now, the good thing is when you create a secured virtual hub, it automatically tells Azure Virtual WAN, hey, there's an Azure firewall or one of the security as a service partner firewalls directly in my virtual hub. Please make that available as a next hop option. So instead of specifying a private IP address, something like 10.3.0.5, I can just select the firewall as my next hop action. And then finally, we've talked a lot about the legacy routing option, right? Before there was this idea of secure virtual hubs. Maybe there was this network virtual appliance that's a firewall or some other type of router. And so maybe behind our virtual network, where we might have said network virtual appliance, lives other virtual networks, right? How would we route to those? Much like that shared service model, we would route things specifically to the endpoint of those network virtual appliances, whether it's the load balancer in front of that NVA or it's the NVA directly. What would that ultimately look like, especially when we add a multi-hub connection? Now, those indirect virtual networks that may be branching off from where your NVA lives, unfortunately, those do have to have user-defined routes. So you need to specify a UDR to point to your NVA VNet. So typically this will be a shared service VNet or maybe a dedicated VNet for your network virtual appliance. And then you need to specify a static route in order to get to those NVA connections. So what will happen is when I create my VNet 2 connection or my VNet 4 connection, I'm going to specify a static route to the endpoint of my network virtual appliance. So that 10.2.0.5 or that 10.4.0.5. And that'll be specific. It'll be static, right? Because I need it to go to that specific endpoint. I'm not just specifying the virtual network connection of VNet 4 or the virtual network connection of VNet 2. So you can see that the default route table will get that static route populated into it because of its default label. So we'll add those in there. And then within the static route connection ID, we'll specify the endpoint that all of that route should go to. And that should be the NVA IP specifically, whether it be a load balancer or again, virtual NIC on the NVA itself. And so essentially what this creates is it makes the virtual networks that are indirect from the virtual hub, they'll get VNet to VNet transitive. Obviously, internet is likely to go out that network virtual appliance instead of going out on-prem or somewhere else. But it does allow us down here in our little HQ office to go ahead and reach those indirect spokes via that VNet 2 NVA that's sitting on 10.2.0.5. So here's a good example of what a route table might look like in your virtual LAN environment. Mine just has a very basic 3 route table setup. You can see default is there because it is standard, and then the none route table is there by standard. And then I went ahead and created a custom route table. I called mine RT VNet. We talked about that RT VNet multiple times throughout various custom routing situations. But as you're creating this route table, you'll see this GUI setup. It'll deploy the route table directly in the same resource group as your virtual LAN instance. You can name it whatever you want. It just needs to be unique within the instance. It does not need to be globally unique in any way, shape, or form. And then you'll give your route a name. Again, just unique within the instance, not globally. The destination type, CIDR is the preferred destination type. However, you can specify a fully qualified domain name if you so choose, if it is supported, and right now it's supported within site-to-site VPN. Destination prefix, so typical CIDR notation, so something like 10.0.1.0/24, and then your next hop will be that virtual network connection that you're specifying. Now, when we talk about adding in that static route, that's this little column right over here where you see next hop IP. So if I have a network virtual appliance that I want to specifically direct all my traffic to go to handle some additional routing, I will hit configure and put in that static IP for that connection. So anything that's going to my virtual network connection of that, so in our instance, right, it was VNet 2 or VNet 4 in the last example, I would configure the next hop IP to be that 10.2.0.5 or that 10.4.0.5. And so any traffic destined for that virtual network will automatically go through that IP first before being forwarded on to its ultimate destination. Labels are a great way to set up propagation across multiple route tables. So this highlights back to our blue and orange VNet example, right? I created a blue label and I created an orange label. Again, I want my orange virtual networks to only propagate routes to other orange virtual networks. Same thing with the blue. So if I associate multiple route tables to my blue VNets or my orange VNets, right, I'm going to assign a label, a common label, so blue and orange, so that they all propagate routes amongst each other, but not with the other virtual networks I don't want them to go to. And then finally, the last two sections are associations and propagations. By default, if you're creating a custom route table, the branches option is grayed out for you. The reason being is you can only associate the default route table to your branch endpoints. So this option will be grayed out for you, and it'll obviously tell you that, hey, your branches are currently assigned to the default route table and they're propagating to the default route table. You can go ahead and choose what type of, how many virtual networks you want to associate your custom route table, 1, 2, 10, depending on the number you have. So you can use that drop down to go ahead and select the specific virtual networks. Now you can associate your route table to a virtual network, but you don't necessarily have to have a virtual network propagating into that route table. So this is not a situation where both the association and the propagation have to have the same route table associated with them. They do not. So select the connections, right, that you will learn routes from this route table, right? So I want my VNet, my spoke 1 VNet to learn routes from this route table. But I may not want my spoke 1 VNets to propagate routes into this route table. Maybe I want my spoke 2 VNet to propagate routes in this route table, right? Or spoke 3. Or I can have my spoke 1. It really is up to you. But just goes to show that association and propagation are two separate things. They are not one and the same. Now, obviously, from a propagation standpoint, yes, we can propagate our route tables into the our branches, so to speak, into our custom route table using the label of default or just toggling the little button that says yes. And so you can propagate your branches directly into your custom route table. And then again, as we talked about earlier, you can select which virtual networks you would like to propagate routes into that route table. Connections can propagate into multiple route tables, so don't think that if I associate a VNet to propagate into one route table that I can't have it propagate into a completely different route table. You absolutely can. It is a many-to-many situation. It's not a one-to-many or a one-to-one type of relationship. And the other nifty thing within Azure Virtual WAN, and I'll show you a nice example of this, is the ability to check the effective routes of your route table, much like you do in a user-defined route situation. You can see the various routes that exist within the selected route table. So if you're needing to troubleshoot an issue or some type of networking isn't working correctly, you can quickly come in here and view the effective routes, right? So that will allow you to check and make sure that, hey, my packet that's destined for this particular VM is being routed correctly, right? It's going through the virtual network connection that I expect, or it's going through the express route gateway that I expect, or that site-to-site VPN, or maybe it's heading over to that virtual hub where it should, right? And then maybe I go over to the other virtual hub and check its effective routes, right? So there's a good chain as a way to kind of help trace the effective routing of what you should expect a packet to perform. So in summary, site-to-site, point-to-site express route connections are all considered to be branch spokes. They associate to that default route table. They propagate to the same set of route tables. They are very inflexible at the current moment. That may change in the future, but as of they stand today, they're only going to the default route table. They must propagate to the same set of route tables. They cannot have custom route tables. They cannot have a site-to-site VPN propagating into one route table and the point-to-site and express route propagating into different ones. It's just not going to happen. Custom route tables are only supported for virtual networks only. Again, that may change in the future, but as a current limitation, they're only associated to virtual networks today. Remember that a connections associate to the route table that they want to learn routes from. So basically saying, hey, I want to associate myself with you so I can learn from you, right? I can learn your routes. And then connections propagate routes to a route table, right? So the route table learns about that connection. So when I choose to propagate, I may choose a route table to be associated to my VNet 1 connection, but I want that route table to learn routes from my VNet 2 connection, my VNet 3 connection, my branch locations, right? So my propagation is my dynamic routing capability that I want to learn about the routes that get propagated into my route table, and then I'll associate that route table to the various connections that need to know about the routes that are in that route table. Specific routes always win, so the more specific you are, the higher priority it gets. The less specific you are, the lower on the totem pole you are. Standard networking methodology from that perspective. If you are going to leverage Azure Firewall, please make sure to set up that quad 0 static route within your route table so you can make sure that you force internet traffic to head out the Azure Firewall and take advantage of that capability. You can view the effective routes on your route tables. Again, great troubleshooting method. If you're not seeing network traffic going where it should, you can look and see, hey, here's my effective route table for this, for that specific table, and it is a table by table basis. So unfortunately, you can't see it as a whole from a virtual WAN instance, but I can select each of the route tables individually and view their effective routes, right? So if I know a certain virtual machine on VNet 1 is not reaching its destination, I can look at that specific route table associated to VNet 1 connection ID and look at its effective routes and see what's going on. And then finally, I just wanted to talk about that none route table. I promised I was going to do that. The none route table is essentially a way for you to propagate connections to where you don't want anything to be learned. It's a black hole. So if I want to effectively isolate a certain VNet, I don't want anyone knowing how to get to that virtual network, I would associate or propagate that VNet connection to the none thing. So say I have 5 virtual networks, VNet 1, 2, 3, 4, 5. I want 5 to be on an island. Don't want anybody to get there. But I do want it to be able to get to other things. So what I would do is I would take that VNet 5 connection ID, and for its propagation, I would propagate to none. So no other route table could learn how to get there. But its route table could receive propagations from VNet 1, 2, 3, and 4. So it could learn how to get to the other virtual networks, but none of the other virtual networks could learn how to get to it. Pretty powerful tool. I just effectively call it the black hole. It is action item number 1 time. It is demo time. We're going to walk through item number 2, which is I created my own Azure Virtual WAN. I use this awesome GitHub repository called the vWAN Playground. Great way to learn and get your hands dirty with Azure Virtual WAN, and we'll kind of walk through the environment and see all the different components and how to set various things up. And then action item number 3, as you walk away from this, hopefully having understand and helped leveled up those Azure Virtual WAN skills, do go take a look at the Azure AZ303 Azure Solution Architect Expert Certification Exam learning path. You'll find additional virtual WAN information within that learning path, or you can also now go to the Azure Network Engineer AZ700 exam learning path. There's more Azure Virtual WAN content in that learning path, as now Microsoft has a dedicated network engineer certification. So I encourage you to go check that out in the AZ700 to get more information and get certified. So here we are in our Azure Virtual environment. Now, in order to create an Azure Virtual WAN within the Azure portal, you can either select the Azure service right up here in Azure Virtual WANs, or you can head up here to the search bar and search for Virtual WANs, and you'll see this little icon come up from this perspective in order to access the Virtual WAN service. Now we can go ahead and hit the Create button over here on the left-hand side, and it will spin up our GUI window to create our Azure Virtual WAN instance. You can select the various subscription you would like to put the Virtual WAN instance into, which resource group you would like to add your Virtual WAN instance. Choose a resource group location. Typically, this will be the same as whatever your resource group is in. So you can see that my existing resource group that I chose is already in the East US 2 region, so that one was automatically selected. Now you can go ahead and name your virtual WAN instance. This does not need to be a globally unique name. It can just be whatever name you so choose, so long as it follows the naming standards as outlined within the Azure documentation. And the Azure Virtual WAN has two types, basic and standard. The main difference between basic and standard is that basic supports site-to-site VPN only. Standard supports everything, all of the new features. So typically, from a virtual WAN perspective, you might leverage basic for exactly that, a very basic site-to-site only or proof of concept perspective, and then you can go ahead and upgrade to the standard type once you move into more of a production or large scale implementation of Azure Virtual WAN. Once you do that upgrade, it is a one-way upgrade. You cannot revert back to basic. You would have to create an entirely new Azure Virtual WAN instance in order to receive the basic status again. And that's it. You can immediately go to review and create, and it'll create your virtual WAN instance. In our case, I already have a virtual WAN instance located here within our virtual WAN resource group. I call mine Contoso-vWAN. It's located over in the West Europe region. And you can see here, once your virtual WAN is created, you get to this basic overview page. It'll give you all of the essential items about which location it's in, resource group, subscription ID. It'll tell you if it's currently healthy. You'll see a icon change here if for whatever reason there ends up being some type of health issue with your virtual WAN instance. So if you see a red, failed, or resetting status appear in the virtual WAN, it's just kind of an easy, quick health check for your virtual WAN instance. As you can see, branch to branch is enabled by default. This means that any branches I connect to my Azure Virtual WAN virtual hub, whether it be user VPN, site-to-site VPN, or ExpressRoute, right, that connectivity is enabled by default. I currently have only one virtual hub within my existing topology. You can spin up as many virtual hubs as there are Azure regions, right? So that number can tick up to 5, 10, 15, right? It just depends on the size of the organization or your organization. And then you can click this little view topology button. The cool thing about this is this launches this new network insights integration capability that they've added to Azure Virtual WAN, much like the Azure Application Gateway or some of the other new network insights features, right? So you can kind of see a step-by-step health check of your Azure Virtual WAN instance. So if you need to troubleshoot something with a bad site-to-site connection or a bad express route, right? You have the ability to kind of drill in and get some of those insights into what may be going on with your virtual WAN instance. And it gives you kind of a nice topology view of your network from a virtual WAN perspective. Now, additionally, we can go back in here and it has your standard activity log where you can see, who's made what changes to your Azure Virtual WAN, what time, and all of that normal auditing capability. It does have RBAC controls assigned to the Azure Virtual WAN instance, so you can assign users to manage your virtual WAN and also apply some tags if your virtual WAN instance is something that you charge back or bill back or need some other type of taxonomy data assigned to the virtual WAN instance. Now, where we get some minor ability to enable some changes within our virtual WAN is within the configuration. We talked about basic versus standard. As you can see up here, the virtual WAN type, basic WAN supports site-to-site only, branch to branch, and branch to VNet within a single hub, right? Multi-hub is not available with a basic virtual WAN deployment. Now, standard virtual WAN supports all of those as well as VNet, ExpressRoute, point to site in a single hub as well as across all hubs. There's a couple of things to note. ExpressRoute to ExpressRoute connectivity, right? So if I have an express route in one region or on one hub, and I have another express route in another region on a different hub, you will need to have the global reach add-on enabled for that express route connection, or it will not work, right? That is only supported if global reach is enabled. All the hubs in standard WAN are in full mesh mode or hub to hub. So you can see, since mine is a standard virtual WAN type, my hub to hub is enabled. I can disable branch to branch if I so choose. So if you already have a WAN solution or some other SD-WAN type solution within your environment and you don't want branch to branch enabled, you can come in here and manually turn it off, but it is enabled by default. And then you can go ahead and save those changes up here at the top and you're good to go. If you need any proof that that's a live demo, I did not mean to click that button, and we got it right here. You can go in here and check properties. You can get the resource ID, your subscription ID, right? Resource group, location, name, all the fun information. You can apply a resource lock to a Azure Virtual WAN. I highly recommend just the do not delete lock. Definitely do not put the read-only lock on this instance, or you will have a very bad day. From a network perspective. Under the connectivity option, you will see all of your various hubs. Now, when you first spin up Azure Virtual WAN, this will be blank for you. So you can actually go up here and go ahead and add a new virtual hub. The region typically will be auto-populated to your default location of the resource group you placed it in. Mine says ECUS2. However, I already... in my instance, my virtual hub is in West Europe, so I can actually populate mine to ECUS2 because I chose a different region. So you can do that. But as you can see, pretty much any region is available to you, even the brand new West US3 region that was recently announced and came online for Azure North America. So just giving you an idea that Azure Virtual WAN is supported wherever. Name just needs to be unique within that virtual WAN instance, and then obviously you need to provide a address space for your virtual hub. I typically recommend that you use a /24 for your virtual hub private address space, just for growth and scalability. You could get away with a /25 if you wanted to, if you weren't planning on adding, say, an Azure firewall or one of the third-party solutions like Checkpoint, iBoss, or Zscaler. But typically, best practice is to go ahead and do a /24 just to be on the safe side. Once you go ahead and put that information in here, and I'll just put test hub as mine, and I'll give this a 192.168.100.0/24. And so obviously the next instances is, do you want to spin up any one of the various gateways? And so we talked about site to site, that gateway scale unit, right? We start off at 500 megs, and then we increment our way up all the way up to 10 gigabits per second. Now you see this X2 next to all the various scale units. That's that active virtual gateway that I spoke about, right? Naturally redundant gateways from a connectivity standpoint. So when you spin up a site-to-site VPN connection, you automatically have an active tunnel. So in case one gateway fails, there actually is already another active gateway there for you handling that traffic. So it is a highly resilient solution. And then routing preference, preferably you would like to use the Microsoft network because Azure Virtual WAN leverages the Microsoft backbone, dark fiber. So please do not choose the internet. You will not be taking any of the advantages of the virtual WAN. And if you need any further information, right, you can hover over this little information icon, right? And this tells you how you can choose to route traffic. Now, the reason why you don't want to choose the internet, obviously, is egress data charges. A public IP address is assigned in virtual WAN to the service based on the routing option. So if you do choose the internet, right, you're probably going to incur a much higher egress charge, and I don't recommend that for that reason. Point to site gateway, same thing, right? You turn on yes. Then you have all of these various scale units. It tells you, how fast the aggregate bandwidth is and the maximum number of clients that it will support. So you'll start off here at about 500, and then again, you can scale all the way up to 100,000 end users. And you can see that's this 200 scale units, right? So 10 gigabits per second per gateway, and there's 20 gateways, right? And it supports 10,000 per gateway multiplied by 10, right? So that's where you get the full 100,000 from. And that was obviously in direct response to the pandemic. Point-to-site configuration. This is exactly how you would set up a normal point-to-site gateway. So whether you use IKEv2, OpenVPN, or some combination of both, your IPsec configuration, whether you use Azure Radius or Azure Active Directory, right? All of that same information needs to be entered. Again, routing preference, and then you would assign a client address pool and any custom DNS servers. You cannot add any more than 5 DNS servers. So please keep that in mind when you're setting up your point-to-site gateway. Express route, same thing. Gateway scale units, increments of 2, so 2 all the way up to 20. You can support up to 8 express route connections per virtual hub. So please keep that in mind when you're configuring your virtual WAN solution. I should note, this is like the virtual network gateway. It takes about half an hour per gateway to set this up. So I went ahead and pre-created the virtual hub in my instance for this very reason. I don't want to have us sit around and wait for a virtual hub to be spun up in our instance. So as you can see, I have my secured virtual hub already created right here in the West Europe region. I just added only a site-to-site VPN, point-to-site. It can be done, just a little more complex. Obviously, ExpressRoute is something a little difficult to demo from this instance, but it's very similar to setting up a normal ExpressRoute from that perspective. So as you can see, once I go into my secure virtual hub, I get my hub status. It's been provisioned, it's green. My routing is green, everything is good, right? So it's just a quick health check on my hub. If there is something wrong, say maybe a provisioning failed or the router is not coming up, right? I do have some quick troubleshooting options up here at the top. I can reset the router or reset the hub to kind of see if that doesn't get my virtual hub back to behaving as expected. Now, depending on what my virtual hub is configured as, you can see I have the various connectivity options, whether depending on which gateways have been installed. So just because I only have the VPN site-to-site, that's the only one that's available to me. If I were to select ExpressRoute or User VPN, there'd be nothing there for me. Now, within my site-to-site VPN, you can see that I have a autonomous system assigned as 65515. This is the default for Azure across any of their site-to-site VPNs. So that same one applies. I only needed a single scale unit. This is just a demo, but it just goes to show you that, this is configurable. So I can change this and scale up if I so choose, if I need to add more connections, right? I'm not limited just to the one scale unit. And then I get some traffic information out of this little instance, right? I can see how many bytes are going in and out of my virtual network gateway. And then I can also view and configure my gateway information. So I can go in here and edit this thing. So again, can adjust the scale units if I so choose. And it gives me the address information for each of my VPN gateway instances, what their public IPs are, what their private IPs are, what their BGP IPs are. And then if I want to assign a custom BGP address, I have that option as well. All metrics and logs are now within Azure Monitor. So if you want to view those options, you have a quick icon to go ahead and select and head right over there. And then down here at the bottom, you will see all of the various VPN sites that have been configured. I just have a single VPN site, which is my on-prem VPN site. So you can see as I select in here within this site, I can edit the site information. So You do want to make sure that you define your device vendor. The reason being is you can download the VPN configuration information. So putting in the correct vendor is a appropriate thing to do. And then obviously whatever address spaces are on-prem or behind this particular VPN instance, you want to make sure you list those out within this site information. And then beyond that, I can go ahead and add an additional link. All right, you want to specify a link name that needs to be unique within this instance. The link provider name, so whether it's AT&T, Comcast, Charter, Verizon, Google, right? Please specify that ISP provider, how fast that ISP provider speed is, so that you can make sure you're configuring the correct aggregate bandwidth, and then make sure you provide the public IP or fully qualified domain name, as that is now a supported feature. And then you can obviously configure your BGP information if you so choose. Now, this will show you a provisioning status for the VPN site. So typically when you do set up a site, it does take a few minutes to obviously negotiate the IKE session. So by default, you probably see a connection provisioning status has succeeded, but connectivity status may be blank for a minute or two as your VPN site tunnel comes up. So just make sure you kind of hit this refresh button up here at the top, and then you should see a connectivity status change. Now you can see when I click the three ellipses down here, I can actually download the VPN site configuration information. This is what helps automate some of those VPN connections that we talked about within configuring automation, right? I can download this, and if I have this similar device across multiple branches, right, I can download this configuration file, and maybe I just need to edit the public IP, but I can use the same pre-shared key, the same device options, all of that information, right? So it makes it very easy to automate the connectivity into Azure Virtual WAN. Now, because I have a secure virtual hub, I can actually hop down in here to the secure virtual hub settings, and it'll give me a couple of hub options from that perspective. However, it does not actually give me the ability to edit any of these security settings. That must be done from within Azure Firewall Manager. And so they include a handy dandy link up here at the top to where I can go to the Azure Firewall Manager and edit those firewall policies. You do get to see which policy is applied to this secure virtual hub, as well as which Azure Firewall resource has been configured. So you can certainly click those hyperlinks to get there and what the status is. Obviously, my security partner provider is blank. I'm not leveraging Checkpoint, iBoss, or Zscaler, but if you were, that option would be filled in with those particular vendors. And then finally down here, before we hop into the routing, you can go ahead and configure that network virtual appliance. So you would just click this option if you wanted to do Cisco, Viptela, or Barracuda and create that network virtual appliance. Now, from a routing perspective, we walked through how to create those route tables and kind of what that status is. So you'll see much of the same within this particular routing instance, but I just kind of wanted to give you guys a little bit of a view of what you can see. So you can see that default route table, the none table, where essentially is the black hole where everything goes to die. And we have our custom VNet route table. So the default route table, again, that's the branch location. So you can see I have a 2 firewall route, right? I want my on-prem device to go out the internet through my Azure firewall. So I will specify that as a destination. I want it all to go to the firewall. You can see that I have that default label because it is considered a branch connection. The default label is applied automatically. And so this little checkbox option that I showed earlier that was grayed out for the custom route table, you can see on the default route table, it is selectable, right? So I can go ahead and toggle this on and off. I don't want to toggle it off because otherwise I would turn off routing for all of my branch connections. But as you can see, the current settings, this is associated to my custom, or you can see that my virtual network is currently associated to the custom routing table. It's not associated to this default one. But from a propagation perspective, you can see that I am propagating routes from my on-prem branches to this route table, as well as to the label of default. Now, if I go into my custom route table, and you can see there's my quad 0 to go to the firewall from my virtual network, and it specifies the firewall network connection. But when I go into propagation, you can see, oh, there's that default label. But you can create your own label, right? So this label is labeled vnet, right? So any other route tables that would have this label as vnet, right, they would get the same propagations as this route table. And you can see I'm not propagating my branch locations into this edit table because I don't want my branches being aware of this particular virtual network instance. But if I wanted it to, I could go ahead and click yes, and it would know exactly where my on-prem locations exist. Now, to view those effective routes, again, you'll just click the effective routes. I can go ahead and choose which specific route table I want to view. So in this instance, I want to view my custom route table. And it'll take about a minute for this to load, right? Azure analyzes the route table to make sure it understands all of the various routes that happen. So you can see I have my default route to go out the internet, and that next top type is the Azure firewall, and it knows to go out the firewall and virtual network connection. And then it's learning that from this default or this RT vnet custom route table. And then it also happens to know where 10.0.1/24 is located. It's a virtual network connection, and it's one of these spoke vnet connections, right? And it's learning that directly from that connection. So there's that propagation in action that we talked about, right? I associated this particular route table to that virtual spoke network connection, right? So it is learning where that prefix address is coming from, right? It's being propagated directly from that virtual network connection. And you can obviously download this information. So if you want to look at it, not in the portal, but on a little CSV file, you are welcome to do so. Now, back in the main page, back where we have our hubs, you can see that the various other options are available. So you can directly look at your VPN sites. You don't have to go into your virtual hub to view them, because the reason is you can directly associate your sites to different hubs. So if I have a virtual WAN instance that says 3 hubs or 4 hubs, right? Maybe I want to have my sites be somewhat independent of that. I can come in here and actually, check mark these sites and quickly associate them to a hub of my choosing, versus needing to drill into each individual hub. And you can see I get some basic information about the hub status, if it's connected, and then what the public IP is of that specific link that I selected. Same thing for user VPN configurations as well as express route circuits, right? I can create user VPN configurations, right, to be used whether I have a user VPN gateway up or not. I obviously don't have any express route circuits currently available to me, but if I did, right, those would be listed here, who the provider was, the type, and if they were associated with the hub. And then obviously your virtual network connections are also found here as well. So any of your vnets that are that have been peered with your virtual hub can be found in here. But if they're not in here, you can go up here to the top and add that connection. Obviously, this works just like a traditional VNet peering, so you need to give it a name, which hub you want that VNet to be associated to, subscription resource group. Do you want this connection to propagate to a black hole, or do you want to associate it to a specific route table and or label? You would do all of that within this little sidebar window here when you set up that virtual network connection. Now, you can actually peer to a VNet that is not within your subscription. That is possible. So you can do multi-tenant VNet peering. With Virtual Hub, you just need to make sure that you have contributor access in that other tenant to go ahead and set up that connection between your Virtual Hub and the remote VNet in the different tenants. So that is a supported situation. You just need to make sure you have the appropriate level of permissions for the identity that will be setting up that connection. Now, there are a couple of monitoring capabilities directly within Azure Virtual WAN. The first being the connection monitor. So you can go ahead and create a connection monitor. So if I just wanted to monitor a connection between my virtual machine and another virtual machine in a different VNet, or maybe somewhere on-prem, I can do that and get that transitive information directly from here. Or I can leverage the new Insights feature, and lo and behold, oh, it's that same virtual network map that we saw earlier within our overview. All right, so the Insights is a very powerful tool from a topology perspective, but also from a metrics perspective. And that's about it. That is Azure Virtual WAN overview. I hope you guys enjoyed this demo, and we'll take it back to our slideshow to wrap it up. Thank you. I'd like to thank everyone for tuning in to see the Azure Virtual WAN Zero to Hero demonstration. Just as a reminder, the Azure Virtual WAN provides ubiquitous connectivity, routing, and security in a unified framework, and just centralizes a hub and spoke topology out of the gate from an architecture perspective. So when you're looking to leverage something like Azure Enterprise Landing Zones, Azure Virtual WAN lends itself naturally to setting up that type of architecture, as well as provides an enterprise scale capability from a VPN perspective, as well as user site-to-site or user point-to-site VPN capability. Thanks for tuning in. I appreciate everyone joining this Azure Back to School event. Again, my name is Derek Smith. I'm an Azure Cloud Evangelist at Trace3. Please connect with me on Twitter at ConsiderCloudDS and on LinkedIn. Again, Consider Cloud with Derek. I love talking to anyone in the Azure community. And if you have any further questions about Azure Virtual WAN or any Azure networking or security related topics, feel free to DM me. I'd be happy to talk to you guys. And thanks again to Dwayne for the Azure Back to School event and inviting me to speak to all of you about Azure Virtual WAN. And I look forward to meeting you out there in the community. Thanks.